Welcome to today's session on data science project, building a data science project from scratch. This is going to be a premium session. I'm Kirthikka Devi Venkataram. I'm a lead at Women Who Code Data Science community. This session is planned for the benefit of our audience to understand the top-down approach in analyzing a data science project in today's world where the artificial intelligence that inculcates or indulges us in or engages us in much more day-to-day activities where we cannot avoid it. As well, we are educating ourselves to understand like what a data science project and how is it getting integrated into the big picture ML. Into the umbrella term machine learning, we also have deep learning as well as many relevant algorithms and approaches, which makes it which makes it significant for us to move forward in a data science project. So let me set the session agenda for today. It's going to be like we will break down a data science project or brainstorm one use case of understanding a business requirement. We try to understand the evaluation metrics and the methods that could be selected beforehand getting into the project. And we also try to improve the project with certain advanced technique using the top-down approach. And we will have a small short talk on implementing our project in a real-time basis using any of the auto ML tool that is available in the market. For our purpose, we'll be using one auto ML tool, which is developed by MLJAR. And there is also going to be a takeaway and perks by means of this brainstorming session that we are going to handle today. Okay, let me quickly get into the session. So machine learning problems are categorized or you can bucket them into four different broad categories, namely the supervised learning, unsupervised, semi-supervised, and reinforcement learning. When we say a supervised learning, when I say, hey Siri, this output is defined and for any relevant input that is given, which is closely mentioned as hey Siri, is targeted as the target is already defined. So we categorize that as a supervised learning method. When we try to create a customer profiling based on the number of profiles of customers which are available in hand, we have different methods of profiling the customers. And that comes under unsupervised learning, where we do not define a set of output data, or we do not have threshold value for any of the data values which is available in the feature list. So there we make it as unsupervised learning methodology. The third way of categorizing a machine learning problem is a semi-supervised method, where we have also seen reading text from a board. Like it could be a handwritten text, or it could be a font which is already known to the machine, where it already has learned that specific font. If it is going to be a different handwriting, then and if it is not labeled, this also comes under semi-supervised learning. In the semi-supervised learning method, we have two more ways of understanding the semi-supervised learning. One could be the transdictive learning, where the data or we learn from the labeled training data and we generalize it to unlabeled data. There is also one more learning methodology, which is inductive learning. This is like it learns from the labeled training data and it generalizes to any new data that is given to it. So there are many information available about supervised, unsupervised, and semi-supervised learning. And today we also have automated machines which are running based on reinforcement learning that started with the development of chess algorithm to be implemented, where the computer has beaten a human in chess game that was built using the reinforcement learning. So let's get into the data science lifecycle. Data science lifecycle falls mostly correlated with the machine learning lifecycle. In spite of the fact, like there are a lot of statistical way or approaches that we use, which makes it to be still more niche to the problem that we deal with. So the data science lifecycle generally starts with the preparation of the data. We do most of the data tactics like like pruning the data as well as to normalize or generalize the data. We then identify the features which are quite relevant to our data science project. In identifying the features, we also get into the details of the importance of each feature based on the outcome or the output that is framed for our data science project. So any data set given to us might be taken or considered by categorizing the features which are available, categorizing it into different feature set which is available in the data set. So there is also tactics involved in featuring the data. Feature engineering is done in a way that makes it relevant for our data science lifecycle, where when we do a kind of operations on a data science project, the features are the selected features are significant, as well as it provides much more value to the project. The third step would be like we build a data science model. Selecting an algorithm and then building a model is the third step. There are quite an amount of information which has been discussed earlier about the number of algorithms for different machine learning problem that has been discussed already. So we will also have a set of generalized and commonly used algorithm for different machine learning problem over here. So once a model is built, we try to find out if the model architecture is fine, or if we do have any feature to be fine-tuned, or if we have any parameter which is specifically mentioned as hyperparameter in all these cases to be tuned. Once hyperparameter is being tuned, we evaluate the performance of the model by fixing certain criteria, and there is also metrics which is available beforehand to decide like if the model evaluation has which is set by the threshold meets our project expectation. So the metric evaluation is also carried out as a last, and the metric evaluation is also carried out at the last step, where we have this as a cycle process which is going on in a data science project. There are different types of classification problem, namely the binary classification as well as a multi-class classification. When we have the data set to be a balanced data set where the target value like 0 or 1 is balanced, then we have a balanced data set and we classify that as a balanced data set binary classification. And we also have imbalanced binary classification problem. So the different ML classification problem uses, apart from linear regression, apart from certain algorithms, these are this generalized algorithms which is available to us, like the logistic regression, k-nearest neighborhood, decision trees, support vector machine, and the naive-Bayes algorithm. Each algorithm is specific, is used in specific application. We can also combine different algorithm and build a model that helps us to solve a unique machine learning problem or a unique data science approach in a machine learning problem. So the machine learning classification problem has certain KPI and metrics which are listed here: the accuracy, precision, recall, FN score, ROC, the region operating characteristic, where the false positive rate over versus the specificity, the false positive rate, that is the specificity over the sensitivity, is plotted. The more the deviation from the diagonal axis, the better the prediction. Generally, AOC is area under ROC. The more the area under ROC, which signifies there is no overlap between the ROC and the diagonal line. When the classifier classifies incorrectly, then we have the area which is equal to like 0.5, and that also means like the ROC and the diagonal line coincides. There we say like the classifier doesn't classify properly. So all these metrics are decided prior getting into the problem. So we also have entropy, Gini index, and the information gain, which which gains its significance in the decision tree algorithm based approach. I have listed few Python libraries which are commonly used Python libraries for implementing the algorithm and for building a model. There are other regression problems, namely the linear regression, polynomial regression, ridge, and lasso regression. They have their own purpose and importance, and we can discuss maybe offline in the Slack if there is any clarification required on any of the regression problem or in any of the specific problem or specific model evaluation method that is required for a business problem. Listed are the ML regression problem, the linear regression, polynomial regression, support vector regression, again, the decision tree regression and random forest regression is all the generally used ML regression algorithm for solving a regression problem. The corresponding KPI and metrics are the mean absolute error, mean squared error, root mean squared error, and coefficient of determination. So when I say mean squared error, it shows the average of the squared difference between the target and the predicted value. They are prone to outliers. Similarly, when we speak about MAE, it is the average between the ground truth and the predicted value. So the absolute value of residual is being measured. The direction of error, like the under predicting or the over predicting direction, is not mentioned in MAE. So when we say about RMSE is the square root of average of the square difference between the target and the predicted value. The scales are generally normalized in RMSE, and they are less prone to outliers. So when we when we know all the details before in hand, we would, after the exploratory data analysis, we would be able to also understand like how far the feature would contribute. And once one specific iteration of an algorithm is run, then we would be able to also channelize on the KPI and metrics apart from the base metric selection that we do. So the R-squared coefficient of determination is like when the R-squared value is 1, the regression is able to capture 100% of variance in the target variable. If it is going to be 0, then it is not able to capture the same. Similarly, I have listed the Python libraries which are generally used for implementing the regression problem. There are also different models that could be built based on these algorithms. They are listed down here. We could also combine using the ensembling tactics. Like we could also combine 2 or more algorithm building a model altogether. So when I say combining it, it could be a blending of model prediction from one model or one algorithm output could be taken out. You could also combine 2 or 3 algorithm model output, 2 or 3 algorithm output, and then combine it into a single model. Or you could also build different models and then blend the model prediction output to make a ensembling method of building an output model. So you could also blend different data which is represented. We will also see in the hands-on brainstorming session where we will have an overlapping data that could be used in different ML that uses different algorithm, as well as that could be represented in different ML specific problem. We also combine the prediction from multiple well-performing model to have final version of our model which could be evaluated at the end. So once the model is selected, we then move to the evaluation phase and its validation methods. listed out are the model evaluation and its model evaluation, and there are certain validation method for selecting this evaluation method for a specific ML model that has been built. So we could have offline discussion about each of the evaluation model selection and how it is directly impacting your model performance and its output as well. So I have also provided a link to the KPI metrics. So if you could click on the link, this is a generic tips and tricks cheat sheet which is listed by Stanford University. You could have a look at it offline. Quickly running into the KPI identification, we will get back. These are the key performance indicators or the quality measure of the model performance. So when I say something like model or how the model is, the quality of the model is evaluated, so there are certain performance indicators. These performance indicators are specific to classification problem in an ML in the ML space, where the first chart gives you the identity of the statistic plot between the class 0 and class 1. It is called the KS chart, which also provides you information or which also quantifies the empirical distribution of the function of the sample. When we see the difference between the class 0 and class 1 to be like 0.5 or more, which means the classification or the measure of classification is in a better way. Higher the KS score signifies that your model is differentiated or the classifier is working in a better way. So here in this particular use case, the KS statistics falls between 0.540 to 0.470. That is what is mentioned over here, which is a measure from class 1 to class 0 that is taken and listed out. The ROC curve, as earlier we have discussed, the ROC, okay, I think this is the first time that I'm mentioning about the ROC curve. The ROC curve gives or signifies about the false positive rate or specificity on x-axis versus the sensitivity. The more the curvature towards the threshold line or the diagonal line, the better the classifier that it works. It is also listed for the target value of 0 and 1. So for this particular use case, the class 0, for class 0 or the target value to be 0, the classifier works at, or the classifier area is 0.83, which means the classifier works at a much more better rate. Similarly, it has been mentioned for class 1. The third one is the precision recall curve. The precision recall curve gives the trade-off between the precision and the recall for different threshold. More the precision recall curve area, better or more, which means the less the false positive rate. This also signifies more the precision and more the recall rate as well. The similar values for a particular use case is mentioned here for the target 0 and 1. So let me quickly go to the next set of qualifiers or the KPI indicators. This is the cumulative gain curve. As the cumulative gain, the gain curve and lift curve are also used as quantifiers, which gives you the more likelihood of receiving a positive response if we have based on the percentage of the sample that we select. So when there is a 20% of sample, the more likelihood of receiving the response is like 0.39, around 0.38 to 39. So this measure of effectiveness of the classification model with the gain curve and the lift curve is also one of the means of measuring what is the ratio of result obtained with the model that is under consideration. We will have a quick intro to AutoML and then we'll get back to this particular slide. So I will quickly move to the AutoML demonstration. So nevertheless of whatever might be the automated machine learning tool that you use, they are going to pre-process the data. It has certain set of algorithm that is being supported, as well as it trains the model, it fine-tunes the model, it selects the hyperparameter accordingly, and then it evaluates the model. So there are a lot of other automated ML tools, like a web-based tool as well as Python library-based tools that are available in the market. So this is one old, which means like it has been released in 2015. This is supported by MLJAR. MLJAR AutoML supports data like numeric, text, categorical, and time series based data. It has inbuilt support of 13 algorithms currently, and it pre-processes in 7 ways of transforming the feature as well as text. It trains model. It supports in 4 ways, as well as it models or it fine-tunes the model using default hyperparameter tuning, and it optimizes the hyperparameter tuning accordingly. So when I say about this, I would also like to give you still more detailed information on MLJAR. You could visit the GitHub page of MLJAR and get to know more about the AutoML tool as such. So this has an ML pipeline where it automatically explorates the data. It initially it conducts pre-processing and then model tuning. Then it moves to training, as well as it explains what it has trained. It evaluates the model, as well as it selects the algorithm based on certain criteria that is inbuilt to the library, which has been developed by the developers. Okay, so this is the coding or the simple code that could be implemented on any of the ways that you want. It could be on Jupyter or Colab. I have implemented in Jupyter Notebook. So you could quickly call or import the AutoML library, and you could also use sklearn model for splitting the dataset and evaluating it through AutoML. There are different modes available, like explain is one mode where you will have explained a detailed explanation of different algorithm and the output and the visualization of the model output is also depicted. So once you run, you will have something like this, like a folder structure which will be formed based on you could have a simple model structure of a folder structure like this, where you will have differentiation of different algorithm based output that is combined in a single folder structure. You could have this as your reference, and you can quickly try to build any of the data sets that so you could quickly build an AutoML based output structure for your simple data set or for testing purpose. So if I have to conduct the model evaluation for a set of data, this is quite easy approach, an automated approach where you do not have to run for different algorithm implementation, and then you do not have to run for building a model as such. There could be an approximated value of model evaluation that is available to the data set which you use. Then you can have a fine tuning of a specific problem dissection, and then you can build your model accordingly. So with this, I am going to quickly jump to this slide where the sharp value, the shapely additive explanation, a feature importance based, which SHAP is a feature importance based approach that signifies the importance of the different features that we have selected from the data set with the different model that has been, with different model or the different algorithm that has been used. So here are the list of features. You don't have to bother about the data science problem or a problem identification currently. We'll just consider like this is a classification problem where the target value is going to be 0 or 1. And we have certain listed features which is available on the left-hand side. You can see the importance or the percentage of or the mean value shows the relevance of this particular feature that contributes towards the model building as well as its decision decision to be taken forward for the certain features which are not contributing towards the model building. Here are listed the sharp feature importance for two algorithms, namely the XGBoost as well as the decision tree. So you could see like for decision tree, the listed down, bottom down listed features are not contributing, which means in addition, if we select the model, we will have to leave out this feature. If it is going to be a feature which has certain significance in our model building, then we are not going to select this model at all. We are going to fine tune in a different way so that that particular feature is getting included. So that is what is the overall idea that we get from this SHAP, sharp feature importance in data science project, and in also handling a machine learning algorithm. Okay, we are pretty much done with most of the details in this session. So let us have a quick hands-on, let us have a quick hands-on on brainstorming a business problem. I'll quickly connect you shortly. So this is the last session that has been planned for today's building a data science project from scratch. This particular section deals with brainstorming a business problem. Unfortunately, I wasn't able to conduct a brainstorming session providing access to you all. So rather, I would give away as perks with the relevant set of details for dissecting a business problem and to like starting from understanding the business problem as well as dwelling down to create a model as well as evaluating the model and improving its performance based on defined approach that we have discussed in the previous session. So in the previous section of this session, the problem statement or the high level understanding of the business problem is we need to devise a solution to prove that The selected location of establishing a school campus will generate revenue, which means the target value is set as 0 or 1 based on the revenue that the school is going to generate once it is getting established. So for this to be accomplished, we need different set of data and not many details that needs to be conducted as market research. We need primary and secondary market research to be conducted in getting the data. For breaking down the high-level problem, for deriving a solution, we need to break down the problem statement into one step further and categorize it into 3 major buckets like customer profiling, cost structure involved, or to understand the expenditure structure of the customer, taking the history of the customer data. Third is the amenities that is being provided by this. So I'm just categorizing it into 3 broad platforms where I am going to collect data accordingly. Say, census data or the data set like lifestyle index data, which is available in the government website, is considered. There are other certain data which is not easily available, like the school amenities. I may conduct primary research by having a one-to-one discussion or meeting with each of the school, or I may also have a data set which is already available. If there are certain specific data that I need to consider for my own business case, like my school campus has this feature, but this is not being listed, this isn't being listed down in many of the schools, then I take that as a new feature and introduce it. So for this purpose, I do a market research as well as I collect a different set of data which is available freely, as well as I purchase data from a third-party vendor. So this is how I approach the problem. In accordance with the problem, the first step is like each of the data set column that we see in the data set could be written or could be projected in this way. Like we have profession, the data of the demographic data of the customer, where the age, gender, race, ethnicity, and the marital status is collected. Similarly, the profession of the individual, like if he is going to be self-employed, first is he an employed person or unemployed? Is he or she employed or unemployed? If he or she is self-employed, if he is going to be a part of a private organization or public organization and things like that. What is the source of income? What are the other sources of income for the individual? Data like this is being collected and it is being profiled in category 1. I have one set of data in category 1. Similarly, I take the census data as well as I coordinate with relevant third-party vendors to understand what is happening with the cost structure of the customer, collecting his collecting the data about his customer, about the expenditure that he generally does. I also understand the family size, the number of schoolgoers in the family, what is the amount spent for each of the person in the family for school, the location of the particular customer, and the distance that nearby schools that are there, what is the savings and what is the expenditure structure, especially for education and things like that. I categorize this as category 2 costing. Similarly, I take on the schooling amenities as a third category or the set of data, where I collect the preference of the customer, like if he prefers to have a boarding school or a residential school or a non-residential school. I also understand the different amenities that generally that the school around that locality or the county offers. Those are being listed down, like the digital classrooms, playground availability, video surveillance support, transportation offered to the nearby locations, tennis court availability, football ground, and things like that. So these are certain amenities which are offered by the school currently. So this kind of data is also collected and it is categorized as third category, categorized in third category. Now, getting back to the problem statement, how do I solve this problem using this data into consideration? So am I going through a data-centric approach or am I following a model-centric approach? What am I doing here? So this approach is like a business problem is given. You're going to approach this from a product perspective, like how you are going to create an overall product or overall solution, making it into a complete product or a complete project. It depends on how you're going to present. It might be a complete kind of prediction app, which is going to be a product, or you only have to design, or you only have to model or validate the data that is available to you, to your senior executive, which is going to be a small set of activity task, and it is going to be a small set of small sub project that you're going to conduct. So it depends on what is the outcome and who are your audience that you're going to project. But if you take this particular problem, and if it is going to be the first time that you do not have any kind of data, this is a complete delusion for you to get like, where should I have to take the data from? And if the data is already available, how should I have to categorize the data? What are the features that I have to concentrate on in this particular problem? What are the intersecting features that will add value? What is the importance of each feature, and what is the algorithm that I'm going to use for solving this problem? When we approach this, it seems to be like a classification problem, if the revenue is getting generated or not. But when you get into the issue, there are many different things which needs consideration. So when I take category 3, like the amenities of school, which is being the amenities that the school provides, that the nearby schools provide currently, there are many different problems that could be solved with this data set. One could be like, you can understand the churn rate, which means the number of dropouts and the number of students who are discontinuing from the school for an academic year because of a dissatisfaction or non-satisfaction with the school management or with the school amenities, which is provided by which is offered by the school. It might also be due to different reasons. We are not going to find out the customer satisfaction here, but instead we are going to understand only the churn rate or the number of students who are discontinuing from a school. This is taken as one issue, one problem, or we can also derive or understand the churn rate with the set of details, with the set of data that is available to you. You can also predict the revenue. Revenue prediction is also possible with the different, still more added data, like what is the expense or what is the like movable and immovable expense that the school invests in getting the or in providing or offering the amenities to their students. So you can also collect those data, put them into this, and then you can also predict the revenue that is getting generated. If you have these two data, like these two problems to be solved, it comes under prediction modeling, and it is a regression problem where we have a continuous value or a real value to be predicted. Here, this makes us to understand, like, we have different data and we also know the algorithm. We can also model using the missing data, which we can also add or collect at a later stage. Then We derive the importance of the feature by using or by modeling with a set of data that is available to us. We also try to, with the algorithm, we also try to build a model. So that model could be like, the prediction model could be like fine-tuned using or identifying the hyperparameter. It could be any of the feature that is given as an input, or it could be any of or it could be the number of epoch or the iteration that we are trying to run on the data which is available to us. It could also be the model architecture that we are building together. So, because this being a regression problem, we know the KPI or the metrics. It could be like MSE, MAE, or R squared coefficient. Similarly, these are the generic KPI and metrics that we know. So when we still go further, we will have specific queries or specific understanding of my prediction or my prediction model should have minimum error. It should be like closer to zero. If that is the case, then you select the KPI or the metric accordingly. So this is how you build a model and select the algorithm as a top-down approach before even knowing about the data set that is there in hand. Let's list down like what is the approach for, or what is the top-down approach that you're going to use. And you are also going to understand like if it is going to be a data-centric or model-centric approach after having a fine-tuned version of hyperparameter. You can decide based on the data that is available if it is going to be a data-centric approach, or otherwise you have to collect still more data according to your problem. Obviously, this is not a data-centric approach. This is a complete top-down approach of analyzing the problem from the product perspective or from creating overall understanding on dealing with the problem. So if I break down further, so I initially take or consider the feature importance. Okay. So okay. The first step would be to understand the feature which has been listed and its importance. The second would be to derive the algorithm that you're going to use. The third would be to build a model. Model selection or building a model. Let me make it as model selection. You can also select a model. The fourth is hyperparameter tuning. And the fifth would be KPI or metric selection. The last is quality measure. So since we don't have to start aligning ourselves with no data in hand, we will just move forward with the whatever the data that we have in hand, and then we try to bring in much more data by performing market research. So if we do not have any data, that would be a complete mess for us, and we need to collaborate with the third-party vendor to collect all these data, and then we produce result accordingly. So when I say this, when we were discussing this category 3, like the school amenities which is being offered and predicting revenue based on that particular approach alone. We do have other approaches like customer profiling is being done. We need to use clustering method for profiling the customer, as we do not know like how many new inmates or immigrants would be there into that particular location and how far it is going to affect. There is also a thin line which is drawn between the unsupervised learning and supervised learning here. If we get new data altogether, where we do not know what is the output that we require for profiling the customer, then it becomes unsupervised learning. Here, we do a semi-supervised learning, like we categorize the customer based on certain lifestyle index data, and then we profile them already. And when a new set of data, when a new set of customer data is available, given to us, then we make a semi-supervised learning approach to profile the customer. So in that particular case, we have to decide on the different metrics, KPI, hyperparameter tuning methodology, the feature importance, and the algorithm that we are going to use. The same thing holds good for every single model, I mean, ML model building approach. So you can have this, I mean, we could have this as a reference, and you can also make an Excel sheet of what are the different set of algorithms that is available for each of the machine learning problem, and you can segregate the hyperparameter tuning, and you can also list down the quality measures like the different types of curve. The visualization speaks more than the data or the figures that we derive out. So you can also list down the quality measures and the relevance of the quality measure with the data that we have in hand. So if we have an imbalanced data set, then we are going to approach, or then we are going to select the quality measure accordingly and solve our, or we try to devise a solution based on the quality measure that we have selected. We also evaluate the model by running different types of model using an automated approach or automated machine learning approach. It could be any device or any tools and technique that we could use to have an overall understanding of the different model that is available. This becomes highly significant when we have the different set of data where we need to combine or join different data sets, and we need to give that as an input. The data pipelining becomes important over here. The operations also becomes important once we devise or once we have a prototype in hand. When we have a prototype, we should have a method to perform operation on a regular basis when we have a similar problem in future. It might not be exactly a selection of a location. It might be like a different approach of transportation, which is being offered to a new location where we have the set of data that is available. We are going to select the important feature that really derives value to that particular problem, and then we do an operations on the operations by sending these data into the data pipeline and building a model accordingly. So we will have a base model to be built, understanding a high-level problem statement, breaking down into many other different problems that could be solved. For each of the problem that is broken down in step one, we can derive the features. We could like forecast which is the algorithm that you are going to use. You can select a model beforehand. You could also tune the hyperparameters. It could be any hyperparameters that could be tuned. It might be one or many as well. You could also have a univariant, bivariant, or multivariant analysis that needs to be performed, where 2 or 3 variants are compared at a time in a multivariant analysis. As well as you could select metrics and the key performance indicators based on the analysis that you're going to perform. The quality measure comes like the diagnosis or the performance measurement of the model, and evaluation criteria is set based on that. You are going to fine tune in each and every step of this, or each and every like to achieve the goal in getting the approach to be like, in getting this approach to be like successful. So this is all about having or dissecting a business problem from a high level perspective to devising a solution based on a machine learning approach. Here exactly you could not have one single algorithm, or you could not have a particular model. Instead, you will have many models which is being built. A blending of model is also required to have or to combine all the results of different categories, different categorized output, where one could be prediction, and the different model output is combined to get the overall output of deriving a solution to the problem statement, if the location is going to generate revenue or not. So I think this is what we will have for today. You can ping me in Slack for any clarification or questions in this for this business problem, or you can also say your feedback, or you can log in your feedback at a later stage. Okay, thank you for listening to me.